Okay, today's session is for the concept of transformer. So this session is for the beginners, ICSE class 10 student, and also for other boards, those who want to get the exact concept of what is the transformer. See, I know that a lot of you maybe already prepared for this, but yes, you are studying multiple times. So I will help you to understand few keywords and the exact principle of how this is working, and I believe that it will help you and it will reduce your time of preparation. Like there is a keyword which is not in your class 10 syllabus, right? That is the mutual inductance. So mutual induction is a keyword of transformer, and so what is that? Let me go to the sequentially. Let's say this is an setup of a transformer. So this blue wiring is the primary coil and this black wiring is the secondary coil. So this blue wire is the primary coil, this black wire is the secondary coil, and if you see that they are not connected. So primary and secondary coil, there is no physical connections. There is no physical connection between primary and secondary coil. But actually what is happening, that we are sending current in the primary coil, and that current is the alternating current. This alternating current means the current is varying. The magnitude of current is varying with time. So, and as all of you know that current produce magnetic field. Now, varying current produce magnetic field. So magnetic field presented by the magnetic flux. So on this secondary coil, those flux is going to expose, right? So that means this this flux, the flux which is just influencing or exposing the secondary coil. So there is no physical connection between the primary and the secondary coil. They are not physically connected. But how they are connected? The magnetic flux produced due to the current in the primary coil is going to expose in the secondary coil. Okay? Secondary coil does not have any source of electricity. Now primary coil influencing secondary coil, primary coil producing magnetic field, primary coil having varying current producing varying magnetic flux. This flux is exposed in the secondary coil. And as all of you know that Faraday's law of electromagnetic induction, change in magnetic flux in secondary coil will produce induced EMF in the secondary coil, and induced EMF will produce induced current in the secondary coil. So this is all about the principle of the transformer. So what are the keyword you have? Keyword is what is the sequence? Like you have the AC current, alternating current in the primary coil. This alternating current produce the AC current is the varying current in the primary coil. Varying current produce varying magnetic flux in the primary coil. This flux is going to expose to the secondary coil, right? Secondary coil. Once secondary coil exposed to magnetic flux, there is an induced EMF, right? So this is all about. Now how they are going to expose each other, like primary coil is influencing this one. This event is called mutual induction. This event is called mutual induction. The depth knowledge is in class 12, right? Science, but yes, this part I am just highlighting so that you can better understand the part, like how the things are happening. The primary coil and secondary coil, they are not connected physically. Just flux is going, moving from here to here. So this principle is called mutual induction. Like mutually they are inducing the flux and producing current. Okay. Now what happened that the coil number, right? So same amount of energy is transferring from primary to secondary coil. Now if I increase the number of turn of coil in secondary, I will be getting the the amplified voltage or EMF in the secondary coil. So that's called step up. Suppose you have 100 220 volt here, you will get like 400 or 440 volt here. So you are stepping up, increasing the voltage in secondary. Now also in real life it's happened that you have the 4000 voltage main current coming from any power station, and in one of the transformer you are reducing it to 440. So it will be step down. So both the things getting applied in our real life. Okay. Now just so this is dear students, so these are the keywords you have to be with you. Now when you are preparing the next time before the board exam, just take a white page and write down the sequence. That's enough. So if you understand the sequence and the principles and the keywords, so it will reduce your time of revision, and also you'll get more confidence on this part, right? So now the mathematical part. What happened that in the transformer? So okay. So let me draw a simplified figure of the same one. So we have like this. So here is the primary coil which is connected to an AC, source of AC, right? Primary. And this is the secondary coil, right? Secondary coil. So what happens? What is constant? The EMF is the constant part, right? And the power. So same, whatever the induced EMF, right? The similar things is going to, this EMF is going to expose to this secondary coil, right? Through change in magnetic flux. Change in magnetic flux, right? And input power should be is equal to output power, right? Output power. So as per the conservation, whatever the input power you have, the same part will move to the output power. And what happened? Just let me, so it's a primary coil, secondary coil, right? Now number of turn in primary denoted by N1, secondary number of coil N2. So you know that if N2 greater than N1, we will be saying the step up transformer. If N2 less than N1, right? So it will be step down transformer. Okay. So you will be getting different conceptual questions from this part, right? And two of the equation you can remember. So this is the that EMF in the primary coil, and this is the EMF produced in the induced EMF in the secondary coil. So what is the same part? The change of flux. Change of flux is same both in primary and secondary coil. So whatever the flux changing here, the same change of flux is going to secondary coil, right? So change in flux, right? d phi dt. Phi is the symbol of flux. So rate of change of flux is d phi. This is constant for both the case. From here we can say that like, so if I do the ratio of EMF will be the ratio of the coil, right? So epsilon naught 2 by 1 N2 by N1. From here we are getting. So this is the fundamental part, right? This is the fundamental part. So now you can say that big deep knowledge on this part. So this is the ratio. Now you want it. So this is the secondary coil. This is the primary. If you want that secondary coil EMF will be greater than primary EMF, right? So what you have to do? You have to make N2 greater than N1. That's it, right? So this is all about this concept. And one more part is the power will be same from primary to secondary. That means EMF into current is equal to the secondary coil. So this is for primary, this is secondary. This is current in primary, this is current in secondary, right? This is the induced EMF in primary, induced EMF in the secondary. So here we are getting that I1 by I2 is equal to induced EMF 2 by 1, or we will be receiving here N2 by N1, right? So this relation is coming from here only. Okay, so that's it for the session. Please follow my session, and I believe that this will really help you to get ready in better way. Before closing, one question like, what is induced current? What is induced current? Induced current is not the very simple current. Induced current which is produced from the induced EMF. Induced current produced from induced EMF. In general current is not induced. So this is the output of the induced EMF, like whenever there is a change in flux. Okay, that's it for today's session. Please follow my sessions, and I believe that this will really help you before board.